Hello, Form 3 students. In today's online lesson, you learned a new formula called slope formula. And in this video, we'll focus on the basic concept of slope formula. Okay, in roughly speaking, slope actually is a similar concept as gradient, but in the later part of this video, we'll discuss the difference between them. So first of all, slope is used on coordinate plane. So if we have 2 points on the coordinate plane, one I call A, the coordinates of A is x, a, y, a, and the other point is B, and then the coordinate of B is x, b, y, b. Then the straight line joining them. Okay, the straight line joining them. The slope of the straight line, slope of AB can be calculated by the formula YA minus YB divided by XA minus XB. Okay? YA minus YB divided by XA minus XB, which is quite similar to the formula of gradient. But one thing I have to remind you, for both numerator and denominator, you have to use the same order to do the subtraction. Means in the numerator, you use y coordinates of A minus y coordinates of B. Then in the denominator, you have to use the x coordinate of A first minus the x coordinate of B. Okay? Or you can change the order. If for the y coordinate you use B minus A, then the x coordinate you can also use B minus A. They have the same value, okay? Same. Just you need to follow the order for both numerator and denominator, but you can interchange the order in both numerator and denominator at the same time. Okay? So these two are correct, but for example, this one, if I use A minus B in the numerator, but in the denominator I use B minus A, then this is a wrong calculation. Okay, wrong calculation. So let's see some example. For example, this question, example 4, in the PowerPoint, it asks you to calculate the slope of the line AB. Okay, slope of the line AB, the straight line joining them. Then you can see that in the solution, we use the 6 and 3, both are the coordinates from point B. Okay, so you can see that it uses the y coordinate of B and x coordinate of B minus 2 and negative 5, both from coordinates of A. Okay, this is A, this is B. So this is y coordinate of A minus x coordinate of A. So follow the same order is enough. Or you can see we have another alternative solution here. This time here we use y coordinate of A minus y coordinate of B, and in the denominator we use x coordinate of A minus x coordinate of B. Both are correct as long as you follow the same order in both numerator and denominator. Okay, so the final answer is 1/2. See one more question. This time you have the slope like this, and then similarly to calculate the slope you have to use both -2 and 1 comes from B, and both 4 and -3 comes from A. So this is one of the solution. And actually I know you know that we have another alternative solution like part A, or alternative solution. We can change the order of both numerator and denominator, like you can use the y coordinates, okay, y coordinates of A minus y coordinates of B divided by x coordinate of A minus x coordinate of B. After calculation, you know that it is -3/2, so they are the same. Okay, just follow the same order in both numerator and denominator, same order in both. So this is a simple calculation of slope. And now I'd like to talk about the difference between gradient and slope. Actually, they're the same concept, but for slope, it is only used in coordinate planes, and for gradients, we used in normal real life, in the reality, like you apply it in geography. But just like what you asked in the online lesson today, for gradients, okay? For gradients, let me write it here. For gradients, from your experience, you know that it is always positive. But for slope, just like these two examples, this is positive slope, but this is a negative slope. Okay, it can be positive, I write this way, or negative. Or actually, we have two more choices. It can be 0, or even it can be undefined. Okay, it can be undefined. But just focus on the first two cases first. Okay, let's consider this one. This is origin O 0, 0, and I have 2 points. One is A, one is B on those sides. This is A, this is B. And then the coordinates of A, let me think about it. Maybe this is -3 and 2. Reasonable, right? And then the coordinates of B is just a reflection of A in y-axis, so it should be 3, 2. Then the two slope OA and OB. Okay, and let me write this way. Okay, just think that this is a block. This is a block. I don't think I should shade it. No. Okay, just think that this is 2 block. If in reality, if you need to walk up OA or OB, actually they have the same difficulty, right? It is as difficult as you can for walking up OA or OB. So for gradients of OA actually equals to the gradients of OB. You can treat it as the steepness of OA and OB are the same, but you can try to calculate the slope of both of them. Slope of OA, let me use O minus A, so it should be 2 minus 0. O here is 0, 0 minus -3 minus 0, so it should be -2/3. And then slope of and then slope of OB should be, let me use B minus O this time, 2 minus 0 and 3 minus O, so it should be 2/3. You can see that the slope of OA and OB, actually they are similar, just different by a negative sign. So actually when you are reading slope, you can treat the number, this part we call it magnitude actually, or you can say that the number, or you can call it magnitude. Okay, the magnitude. The number part refers to the so-called steepness of the slope, and the positive sign, actually this is, we have an invisible positive sign here, right? The positive sign and negative sign refers to the direction of the slope. Okay? Whenever, just follow the Chinese number 8. How can you write a Chinese number 8? Okay, Chinese number 8 should be written in this way, right? Chinese number 8. For this direction of slope, it always has a positive slope. For this direction of slope, we always have a negative slope. Just like this one, this is the first stroke of Chinese number 8, so it has a positive slope. And this one is similar to the second stroke of a Chinese number 8, so it has a negative slope. Okay, so for quick memorize, you can memorize in this way: a Chinese number 8, the first stroke positive, the second one negative, positive, negative, positive, negative, positive, negative. Okay, or positive, negative, positive, negative. Okay, so when you know the direction, we can discuss more things. The zero and undefined cases. Actually, they are used for horizontal line and vertical line. Okay, horizontal line, vertical line. Consider this way. If we have a horizontal line, okay, let me create a case. For example, if I have a point A here, just use -3, 2, never mind. Then for horizontal line, if AB forms a horizontal line, the y coordinates of B should equals the y coordinates of A, which means 2. Then I create any x coordinates I like maybe 2 also. Then the line joining AB is a horizontal line. Okay, this is a horizontal line. Let's try to calculate the slope of AB. Okay, difference of y coordinates minus difference of divided by difference of x coordinates, sorry. You can see that as they form a horizontal line, the y coordinates of A and B are always the same, which means the numerator here, actually, here we are subtracting both y coordinates. This is the difference. Difference of y coordinates must be 0. The difference of y coordinates of a horizontal line must be 0. So for horizontal line, when we calculate the slope, we always have a 0 over the difference of their x coordinate. This is -5 this time. So for 0 divided by any number, the answer must be 0. Okay, the answer must be 0. So for horizontal line, the slope is always 0. The slope is always 0. In another way, for vertical line, for vertical line, okay, let me create another case. A and B. So this time A, maybe we have 3, 3. As AB forms a vertical line, the x coordinates of them must be the same. So B should have x coordinate 3. And then let me create the y coordinates. Then when you are calculating the slope of AB, okay, take the difference of their y coordinates divided by the difference of x coordinates. As they form a vertical line, the x coordinates of them must be the same. Therefore, when you're taking the difference of x coordinate in the denominator, it must be 0. It must be 0. So whenever you are calculating the slope of a vertical line, the denominator is 0. And then for this case, the numerator is 7. However, just recall we learned in maybe primary school or Form 1, can a denominator be 0? Can we divide 7 things to no people? And then how many things of each of them can have? It is not reasonable, right? It is not reasonable. So we call it undefined. Undefined. We can never divide something by a 0. Okay, we can never divide something by a 0. We cannot define the value of it. If you want to know more about this one, why is it undefined, you can ask me individually. I won't talk about it here. But whenever we have a 0 in the denominator, the answer should be undefined. Okay, we can't divide the number by a 0. So we can see that if it's a vertical line, the slope is undefined. So let's have a little conclusion here before we go back to examples. To distinguish between positive slope, let's start here. For a slope, gradient is used to talk about the steepness of a road. And then for the slope, the number part, the magnitude part here actually refers to the steepness, how difficult you can walk up the slope. And then for the positive side or negative side, actually it is talk about the direction of the slope. To distinguish between the positive slope and negative slope, you have a trick here. Use the Chinese number 8, the first row, positive. The second slope, negative. Okay, positive, negative, positive, negative. We still have two more cases, zero and undefined slope. For zero slope, it is a horizontal line. For undefined slope, it is a vertical line. Okay, to memorize all this in a quicker way, I suggest you may use this way. Just think about if you have a clock. Yes, beautiful. Okay, if you have a clock, you will have maybe hour hand or minute hand, never mind. This is 12. 1, 2, 3, 4, 5, 6, right? Okay, when the maybe minute hand walks the first half of the clock, it runs in this way. First of all, this one, and then later it points here, later it points here, later it points here, and finally points to 6 for the first half. Okay, actually it starts like this. This one is undefined, and then when it moves a little bit, okay, clockwise, it is a very, very large slope. Okay, very, very large slope. And then smaller slope, and then keep decreasing. This is 0, and keep decreasing, and decreasing. Okay, so when the minute hand walks from 12 to 6, actually it starts from undefined slope, and then when it moves a very, very, very little bit here, it is a very, 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 very huge, very, very large slope. Okay, and then keep decreasing. Okay, up to here, when it points to 3, it is 0 slope. So for the first part here, it is the area for positive slope, and then when it moves to 3, it is 0. Okay, from positive to 0, so keep decreasing in the first quarter, and then from 3 to 6 means in the second quarter here. Actually, this is the quarter for negative slope. Okay, this is a quarter for negative slope, so it keeps decreasing, from 0 to a very, very negative number, even more negative number to even more negative number, and finally go to 6 here, go back to undefined. Okay, so this is the way, a trick or in a quick way, how can you compare the slope of different straight lines. If you just want to distinguish between positive and negative, use this way. If you want to compare their size, you can use this way. Okay, so go back to our examples here. Where is it? Okay, just like this one. Focus here. Without calculation, although it tells you that the slope is -3 and -0.5, if I just rub off this two, okay, don't let you to see it. Rub it off. Can you directly tell me, by just reading from the graph, whether the orange line, which one, or the orange one or the green one, has a greater slope? Okay, first of all, both slope are negative. Okay, both slope are negative, because by Chinese number 8, positive, negative. So no matter this one or this one, both of them are negative, similar to the second slope of the Chinese number 8. Okay, both are negative. And then when you move maybe the end of them together, this is the green one. Let me use, can I have green color? Okay, this is the green one, and this is the orange one. So you can see that if you follow the clock, for the minute hand moves, will first goes to the green one and then goes to the orange one. So the green one has a negative slope but less negative. The orange one has a more negative slope. Okay, therefore the green one has a greater slope. And then for the orange one, we have a smaller slope, just like this one. Okay, so maybe there will be some exercise for you to directly read from the graph and write the slope in maybe ascending order or descending order. Okay, so actually, to compare the slope or just write down their positive or negative slope, it is quite a difficult task, but try to overcome it. Go back to some easier examples here. Okay, for example, we have to calculate the value of k, and you know that the slope between a and b is 1/3. So by using the slope formula, you can set an equation like this. This is the y coordinate of b minus the y coordinate of a, and then x coordinate of b minus the x coordinate of a. Follow the same order. That's enough. And then solve it by yourself. And then this one. This is similar to the example that Mr. Kai talked about in today's morning. Prove that these 3 points lie on the same straight line. For the same concept, lines on the same straight line, sometimes we'll use the word collinear to represent it. Collinear. If we say that, okay, some points are collinear, means they lies on the same straight line, because you know that for any 2 points like this, you can always use a straight, not straight enough. You can always use a straight line to pass through them at the same time. However, for any 3 points I draw, usually you will form a triangle instead of one straight line passing through them. So occasionally, I can draw 3 points that can use one straight line to pass through them. In this case, we call A, B, C, this point are collinear. Okay, fall on the same straight line. Okay, so come back here. How can we make use of the fact collinear, or how can we prove that they are collinear? Actually, we have different ways, but in this section we are talking about slope, so we suggest that you can use slope. Okay, as AB and AC lies on the same orange straight line, so the slope of either AB section or BC section, both line segment, should have the same slope, because slope is discussing about the steepness, the direction of the straight line. As ABC line on the same straight line, they should have the same direction and same steepness, right? So the slope of AB and slope of BC are the same. So slope of AB, slope of BC are the same. So by calculating these 2 slopes, you can see that, okay, as both slopes are the same, so they lies on the same straight line, or say that they are collinear. Okay? As this chapter we're talking about slope, I hope you can use slope to calculate it, but actually we have many alternative ways. I can talk about them here. The first one, in today's online lesson, some of you talk about the angle called inclination, but we'll talk about it next time. This is a possible way, but not always used. Or in a second way, we can use AB plus BC equals to AC actually, because you learn about it actually. Okay, ABCB is the middle one, then the first section AB plus the second section BC, if the total length equals to the whole part AC, then they are collinear. Because if we have 3 points that are not collinear, ABC here, then the line AB and the line BC and the line AC should have a relation like AB plus BC, always greater than AC. This is by triangle inequality you learned in first term. Okay, so if you find that the sum of them equals to AC, then they are collinear. If not, they should have some kind of this relationship. But focus back, this section is talking about slope, so I greatly suggest you can use slope to calculate it. So this is the end of this section first. So I will give you some homework in, not this one, in your self-assessment booklet. Okay, bye.